Okay, so this video will cover section 2.1, and it's about solving linear equations, part 1. So there'll be two parts. And solving linear equations is one of the key things to know how to do in order to do algebra. But first, let's define what a linear equation is. We're going to define a linear equation in one variable. So what makes something an equation, which I'm sure you've seen, it's two statements that have an equal sign in between, saying that they're equal to each other. So a few examples, probably simplest possible example, something like x equals 3. Or we could say like x plus 2 equals 1. Or maybe something like 3x plus 1 equals 2. So these are all equations because they have our equal sign. So it makes it an equation. The things on either side of an equation we call expressions. So 3x plus 1 would be an expression 2. Even though it doesn't have an x or anything, we can still call that an expression. And it's an equation because we are saying that these two expressions are equal to each other. So look at these three and see what they all have in common. They're all equations because they all have equal signs. And they all have an x. The x is what we'll call our variable. So you'll often see x or y, z. It could be any particular letter used as kind of a placeholder. That could take on any number of values. In a linear equation, they tend to take on a single value. Like in this first statement, we say x is equal to 3. We can already see what it's equal to. So that would be the one variable part of this. We have something like x or y or a, b, etc. Now, what makes this linear is the fact that you don't see any exponents on your variable. In each case, these x's have, we could say, an imaginary exponent of 1. We typically don't write that, we just leave it as x. So it's linear if you don't see any squared values. If this happened to be x squared equals 3, it would no longer be linear. So I would say no exponents greater than 1. The textbook gives us a more specific definition, so let's write it out here. So they say a linear equation in one variable is an equation that can be written in a particular form. So it's an equation that can be written in the form ax plus b equals 0. And they go on to say where a and b are real numbers and a is not equal to 0. So this ax plus b equals 0, this is a general form where a could be any particular number, b could be any particular number, but we have this extra condition that a cannot be equal to 0. Because if a was equal to 0, it would multiply with the x and basically delete it, and we would end up with just b equals 0. So it would no longer be a linear equation in one variable. We would lose our variable. So that's an extra condition there. So this is the general form. Each of these, even though it might look somewhat different from ax plus b equals 0, can at least be put into that form. And we'll talk a bit about how we can move things around using algebraic techniques. So let's leave this and see some examples. So here we will use the addition and subtraction properties of equality. And the textbook gives us these statements. They define it. They say, let A, B, and C be expressions representing real numbers. So the first statement says is if A equals B, then A plus C equals B plus C. The second statement says if A equals B, then A minus C equals B minus C. All this is really saying is that you can add or subtract a number from both sides of the equation, and it's still true. So this is a technique that we can do to solve an equation. So let's look at a couple examples. So in example A, we have x minus 8 equals 3. And it wants us to solve each equation and then also check the solution. So by solving an equation, it means that we want to get to a point where we have our variable x on its own on one side of the equation equal to some number. We can find out what x is equal to in order to make the statement true. So this is saying we have some number and we subtract by 8, and then we should get 3 as the result. And you might be able to just reason in your head what that number would be. This is a pretty simple example. But we can use these properties in order to find it out more procedurally. Basically, what we want to do is move everything that's not an x, so like this minus 8, we want to move it over to the other side of the equation. Another way to say that is we want to cancel it on the left side and move it over to the right side. So in general, if we want to move a number to the other side of the equation, we would do the opposite operation of what's happening. Like here we have x minus 8. If I want to move it over to the right side, I would add 8 to both sides. And you can write this kind of like an addition procedure. And here you can see that the 8s will cancel. Minus 8 plus 8, those cancel out. So we'll just get x left over on the left side. And on the right side, we have 3 plus 8, which will give you 11. And that will be our solution. We've solved it. In the homeworks, they like to have you express things as a solution set, which involves these curly brackets. A set is like a container, so we'd say this is the set containing 11. That's the solution set. We might have more than one numbers as a solution later on, for now, and as we'll see in general with linear equations in one variable, we'll get a single solution, just a single number. And if you go back and look at the top, this can count as checking the result. We had x minus 8 equals 3. If we want to check it, we can go back in and plug it in. So since x equals 11, I can say replace the x with the 11. 11 minus 8, that is indeed equal to 3. So that would be checking our solution. So it's a good procedure to do because it will let you know if you have the right answer. Let's say we made a mistake in our arithmetic and we got like 10 as the result. And then we plug it back in. 10 minus 8 is not equal to 3. This is actually equal to 2. So that would tell us we made some kind of mistake. So this was the notation for a solution set, just as a heads up. So just make a note, in general, if we want to move a number to the other side of an equation, in general, you want to do the opposite operation. On both sides of the equation. So that means if there is an addition happening, you would want to use a subtraction. If there's a subtraction happening, which is what we had in our case, you would want to use an addition. If you had a multiplication, you would want to use division. And if you have division, you would want to use multiplication. So addition and subtraction, opposite operations, multiplication and division, opposite operations, and you can say vice versa. So we'll see some more examples of these. So let's look at example B. This one says -5 equals m plus 4. So we want to do the same thing. We want to solve and then check our solution. Notice this time the variable is on the right side of the equation. It can be on either the left side or the right side. A lot of times you'll see it on the left side. Commonly, a lot of students like to move it over to the left side to solve. But you can keep it on the right side if it's easier. Sometimes it'll be easier to do that. So I see I have 4 being added to m. I want to solve, which means I want this m to be on its own on one side of the equation. So I want to move this 4 over to the other side. And since it's being added, I'll do the opposite operation and subtract the 4 from both sides. So here we have our first example of working with negatives. It can be a little bit tricky. So we have -5 minus 4. I learned to write this as -5 plus -4. If you're subtracting from a negative, this can help you see maybe a little more easily that the result will be -9. Another way to think about it, -5 minus 4. If you're subtracting from a negative, you're $5 in debt, and then you spend $4 more. So that number should become more negative. You're now $9 in debt. So this result will be negative 9. And on the right side, we still have the m. M drops down. 4 minus 4 is 0. So we can leave it there. If you want to flip this around and say m equals negative 9, that's okay too. You can write it either way. Or we could say the solution set is negative 9. And then let's check. So we're saying that m is equal to negative 9. So let's plug it in. Negative 5 equals, instead of m, I'll say negative 9 plus 4, which is equal to negative 5. So it's true. So that's using addition and subtraction in order to solve an equation. We're basically moving the extra number over to the other side of the equation. Now let's practice using multiplication and division properties of equality. So just like we can add or subtract a number from both sides of an equation, this is just saying if a equals b, then a times c equals b times c. You can multiply a number on both sides of the equation. Also, if a equals b, then a divided by c equals b divided by c. You can divide a number on both sides of the equation. And you have to do it on both sides. That's sort of the key to make sure that things stay equal. So let's give a couple examples. The first one we have is 3 times k equals negative 9.6. So we have 3 multiplied with k. We want to move this over to the other side. So since it's being multiplied, I'm going to divide both sides by this number, by 3. Divide by 3. This will cancel the 3 on the left side. We'll end up with k, and then negative 9.6 divided by 3. Can plug that into a calculator. You should get negative 3.2. We could also do some long division. So the negative, we have a positive divided by a negative, so the result will be negative. 3 goes into 9 3 times. Move up the decimal. 3 goes into 6 2 times, negative 3.2. So that will be our solution, and you can check this by plugging it in. 3 times k, we're saying k is negative 3.2. This will be equal to negative 9.6. So the result is true. So in example B, we have negative m equals 19. We want to, in the same way, move this negative over to the other side. Another way we can see this is the negative is like a negative 1 that's being multiplied by the m. So we can divide both sides by negative 1. That will cancel on the left side. And when you divide a number by negative 1, it basically just becomes negative. So we get that m equals negative 19. Basically just moves the negative over to the other side. Now this can become more complicated when we have more than one term. We just had 19 here. If there's a single term, the negative kind of just moves over, hits the other term. So we'll say our solution is m equals negative 19. All right, example C. We have x divided by 4 equals 5. This time we have a division happening to our variable. So we'll just do the opposite operation. If I want to move something that's being divided over to the other side, I'll want to multiply. So we'll multiply both sides by 4. Can write it out like this. On the left side, these will cancel because that's like a 4 over 1. And on the right side, 5 times 4 will equal 20. So we'll say x equals 20. All right, let's squeeze our last example in. So for D, we have 3 over 8 y equals 12. So in this case, our variable, and notice they swapped our variables for x and y. It's still a linear equation in one variable. We've just given it a different name. We just called it y instead of x. So notice here it's being multiplied by a fraction, 3 over 8. There's a couple different ways that we can solve this. We still want to move everything that's not y over to the other side. So one way we can look at this, we can move this y up into the numerator. So we can write this as 3 times y over 8 equals 12. This might be a little easier to see. There's sort of two things happening here. The 3 is being multiplied by y, so y is being multiplied by 3, and then there's a division happening also. It's being divided by 8, so there's multiplication and division happening. So one way to do this is to solve it in 2 steps. We can first move this 8 over to the other side by multiplying. So we'll still have the 3y on the left side. 12 times 8 is 96. So we've cleared it up a little bit. Then we can do a second step of dividing by 3 on both sides. So that will clear the 3 on the left side. And then 96 divided by 3 is 32. And that will be our solution. So that was actually our first example of a two-step equation, an equation that took 2 steps. We could also solve this in 1 step. So slightly more fancy technique. Let me rewrite the equation, 3/8 y equals 12. So a trick for clearing out a fraction is to multiply by the reciprocal. So the reciprocal means the flipped version of the fraction. Oops. Let's keep it here. So I could multiply both sides by, instead of 3 over 8, 8 over 3. So this basically clears both the 8, the 8s will cancel, and the 3s will cancel at the same time. So you're kind of doing 2 moves in one. So on the right side, we can view that as 12 over 1 times 8 over 3. multiplying two fractions, so multiply the numerators. 12 times 8 is 96. Notice we have our 96, and then 1 times 3 is 3. 96 over 3 again. And then our result will be 32. Same thing. So just doing this to show that there's multiple ways to solve these equations. As long as you're following the rules and just being careful, you'll still get to the same result, same destination. Some ways might be more simple, more complicated, take more or less steps. You might be more or less familiar with some ways. It doesn't really matter what you do. You'll kind of pick up tricks along the way to see which ways you like and which ways are easier. But that kind of just goes into the style of solving equations. You'll pick up your own style. But I just say this to say there's multiple ways of solving an equation. All right, so let's take a more general approach. Now we want to solve, we'll combine a few of our techniques here. So we're going to generally solve equations that are in this form, this linear equation in one variable. So our general strategy will be to move everything that isn't your variable to the other side of the equation. And I'll add a subnote here. You want to start with what is not attached to the variable. And we'll see what I mean by that. Let's look at our first example. We have 3p plus 7 equals 31. And I'm wanting to solve, which means eventually I want to get to a point where I have the p on its own on one side of the equation equal to some number. P equals something. Some value of p that when I plug it in, multiply it by 3, and then add 7, I'm going to get 31. So this is a little bit harder. Maybe you can just look at it and see what that value should be. But this is where it becomes more useful to use these algebraic techniques. We can procedurally, step by step, move things over to the other side until we have our variable left over. So sometimes students want to start by trying to get rid of the thing attached to the variable, but you always want to start with everything that's extra. So that's what I mean by what is not attached to the variable. So I'm going to first focus on this plus 7. It's being added, so I want to subtract 7 from both sides. That will cancel on the left side. I get 3p equals 31 minus 7 is 24. So first step, I've cleared out the 7. Now I can focus on what's attached to the p, this 3. I'm going to divide both sides by 3. It will cancel on the left side. I just get the variable left, and then 24 divided by 3 is 8. Then we have our solution, and you can check it, plug it back in. If we do 8 times 3, and then add 7, we should get 31. So here we're combining both the addition and subtraction and multiplication and division properties of solving equations. Okay, let's look at example 4. Now we have negative 6/5 c minus 1 equals 13. Let's make this 6 look a little nicer. All right, starting to get a little more complicated. We have a fraction, a negative, but first let's just move what is not attached to our variable c. This time we're using c as the variable over to the other side. I want to move that negative 1 over. So I'll do it by adding plus 1, both sides. So I still have negative 6/5 c. 13 plus 1 is 14. Now here we have, I'm going to see this as negative 6 over 5. So I'm going to do this in 2 steps. We could also multiply both sides by the reciprocal. I tend to like to do the 2-step method, but it is up to you. So I'm going to first multiply, since the 5 is being divided. If there's a number on the bottom of a fraction, that means it's a division. So I'm going to first multiply this 5 over. That means it will leave the left side. I'll still have the minus 6, still have the c. 14 times 5 is 70. And then now I have negative 6 times c, so I can divide both sides by negative 6. You can bring the negative along with you. You can do those both in one. So it'll cancel on the left side. I'll get my c. 70 divided by 6. If you type that into a calculator, you'll probably get a decimal, 11.66666 repeating. So that means it doesn't divide cleanly. So what we typically need to do in this situation is reduce the fraction. We can divide both the top and the bottom by some number and try to make them as small as possible until we can't divide them both by the same number anymore. So it takes some time to try to see which number we should divide. If I notice that they're both even, I can at least divide them both by 2. So I can divide the 70 by 2, and I can divide the 6 by 2. And since we have a positive number divided by a negative number, the result will be negative. So usually you'll see the negative brought up to the numerator. 70 divided by 2 is 35. 6 divided by 2 is 3. So this reduces to negative 35 over 3. And then we can repeat the process. We can see, is there something we can divide them both by that will make them smaller? We could divide them both by 1, but they would stay the same. And then 35 is not divisible by 3. So in this case, we'll just leave this as our result. So when you're doing the homework questions, the system will be looking for the reduced fraction. So just as a heads up, if you were to type in 70 over negative 6 or negative 70 over 6, it will likely count that answer incorrect because it wants the reduced fraction. So you always want to see, can I reduce the fraction beyond what it currently is? All right, let's look at example B. This time we have some decimals. Negative 8.85 equals 2.1y minus 5.49. This time our variable is on the right side, which is okay. We can leave it over there. We have decimals, but let's just use the same process, follow the same rules. I'm going to move the term that is not attached to the y over to the other side. So it's being subtracted. That means I'll want to add, do the opposite operation. I'll add 5.49 to both sides, plus 5.49. Negative 8.85 plus 5.49 should give you negative 3.36. And this is canceled on the right side, so we'll get 2.1y. Oops. Stick with the same color here. Now I'm still solving for y, not done yet. The 2.1 is being multiplied by the y, so I'm going to divide it from both sides. Divide by 2.1, divide by 2.1. Negative 3.36 divided by 2.1 is negative 1.6. Now that'll just be equal to y. So we can flip this around if you want. Y equals negative 1.6. You can always swap sides of equality if you want to. So we could have done that in the beginning if you're really used to having your variable on the left side. But again, doesn't really matter either way. Whatever you're comfortable with, whatever is your style. So that'll be our solution. Or again, the homework likes to use solution sets sometimes, so it might give you some curly brackets, and then you would just put the negative 1.6 inside. That's the set of solutions. All right, just to add a few more extra steps. Here we're solving equations. I think this is supposed to be with with variables on one side of the equal sign by combining like terms. And the textbook gives us some procedural steps. So first, just look at our example. We have 4x plus 9 minus 6x plus 2 equals 17. So definitely more complicated than what we've seen. So it gives us a list of procedures. So sort of like a game plan. Step 1, it says to clear parentheses and combine like terms on each side of the equation. To me, I call this cleaning up the equation. Step 2, they say get the variable on one side of the equal sign and the constant on the other side of the equal sign, aka isolating the variable. That's what we mean by solving, go through some process, and then we'll get just x on one side equal to something. Or maybe there's still something, attached to the x. So move everything that's not attached to the x over to the other side. Step 3 says solve for the variable, so either by using multiplication or division. So these two steps together, that's what when I say like moving everything over. That's what I mean. And then step 4, they like to say to check the solution. It's always good to check. All right, so let's see an example. So we have 4x plus 9 minus 6x plus 2 equals 17. So notice there's multiple x's. We have this x, 4x, and then the minus 6x. And then there's a few terms that don't have an x. So we want to combine our like terms. Like terms either have the same variable. So for instance, this 4x and this negative 6x are like terms. And then just regular old numbers that don't have a variable, like the 9 and the 2, these are also like terms. So we can combine those together. The 4x, and you might need to go off on the side, do a little scratch work. We have 4x and then minus 6x. That result is 2x, negative 2x, I mean. And then we also have 9 plus 2, which is 11. So this can simplify. 4x minus 6x, I'll combine that to the minus 2x, and then 9 plus 2 is 11. So it simplifies to minus 2x plus 11. We still have equals 17. So what we've done is there's step one. We've, in this case, there weren't any parentheses, and we've combined like terms on one side of the equation. Now we're like what we've had before. So we have this plus 11. I want to move it over to the other side by subtracting minus 11, minus 11. So I still have the negative 2x. Those 11s cancel out. And then 17 minus 11 is 6. Next, we would divide both sides by negative 2. And I get that x is equal to negative 3. So if I wanted to check this, I would return to my original equation. We had 4x plus 9 minus 6x plus 2 equals 17. And everywhere there's an x, I'm going to replace that with negative 3. 4 times negative 3 plus 9 minus 6 times negative 3 plus 2 equals 17. I use these parentheses around the negative to help show that the negative is attached to the 3. And when you see a number next to parentheses, it means that they're being multiplied together. So 4 times negative 3 is negative 12 plus 9. Negative 6 times negative 3. A negative times a negative is a positive. So we get plus 18 plus 2 equals 17. Then add this all up, negative 12 plus 9 plus 18 plus 2, that will all become 17. 17 equals 17. True. If, say, we plug this number in and we get something like 2 equals 17, something that's not true, that would mean that we've made some error. We did not find the solution. So, just to show the checking process. All right, another example here. We have 2 times 1 minus 3h minus 5 times 2h plus 3 equals negative 21. So when you have, notice we have some parentheses here. And the first step in their process was to clear the parentheses. When you have a number in front of a set of parentheses, we call it distributing it to both terms. It multiplies to everything inside. And here, this negative 5, the minus would come with it too, will also distribute to both terms. They're going to multiply. So in the first case, 2 times 1 is 2, and then 2 times negative 3h will be negative 6h. Next, we're distributing the negative 5. Negative 5 times 2h is negative 10h. When those multiply, you just multiply the negative 5 and the 2, and the h is still attached to it. And then negative 5 times positive 3 will give us negative 15. This is equal to negative 21. So we've distributed, gotten rid of the parentheses. First we distribute. Now we can combine like terms. So let's see what like terms are. We have negative 6h minus 10h. That will give us negative 16h. Subtracting from a negative, the result is more negative. And then we have 2 minus 15. That will give us a negative 13. So negative 16h minus 13 equals negative 21. Now let's add 13 to both sides to clear out the 13. So we still have the negative 16h. And then 21, negative 21 plus 13 will give us a negative 8. We can also see that as 13 minus 21. Last step is to divide. I'll divide both sides by negative 16. So that'll cancel. On the left side, you'll get h. Negative 8 divided by negative 16. We have a negative divided by a negative, so the negatives are going to cancel. And then we have 8 over 16. 8 divided by 16 gives us a decimal, should give you 0.5. If we want to keep it as a fraction, we can divide the top by 8, divide the bottom by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. We can just see that 8 goes into 16 2 times. It goes into itself 1 time. So the result is 1/2. All right, let's take a look at our last example. So we have 1/2 3b plus 8 in parentheses, so that's being multiplied, plus 3/4 equals negative 1/2. So we have a lot of fractions. So we'll need to recall how to add, subtract, multiply, divide fractions. Definitely need all of those skills. And later on, we'll see some techniques to maybe clear out the fractions. But let's stick with them for now. So we'll follow the same process. First, I want to distribute. I'm going to distribute the 1/2 to both terms. When you multiply by 1/2, it's the same thing as dividing by 2. Another way we can see this is that this is like 3b over 1 plus 8 over 1. When you're multiplying fractions, multiply top times top, bottom times the bottom. So 1 times 3b is 3b, and then 2 times 1 is 2. 3b over 2 plus 8 over 2, which will become a 4. We'll leave it like that for now. Yeah, let's leave it like that for now. So now we want to combine like terms. In this case, these two will be our like terms. So we want to combine Let's make a little scratch work area here. We have 8 over 2 plus 3 over 4. So we want to add two fractions. So to add two fractions, we need a common denominator. So I want to multiply one or both of the fractions by something in order to change the denominator to be the same number. Here, if I multiply the 2 by 2, I can make it equal to 4. So I'm going to multiply the first fraction by 2 over 2. So that makes it 16 over 4 plus 3 over 4. Now that they have the same denominator, I can add them together. So 16 plus 3 is 19. And when you add or subtract fractions, the denominator stays the same. So 19 over 4. So I've got 3b over 2. So this combined to 19 over 4. This is still equal to negative 1/2. Now let's move the 19 over 4 over to the other side. So I want to subtract that from both sides. So let's just write this out. Still got the 3b over 2. It's cleared out on the left side. And now what I have is negative 1/2 minus 19 over 4. So I have a subtraction of fractions. So same rules apply. I want to get a common denominator. If I multiply the negative 1/2 by 2 over 2, I can get a 4 in the denominator. So I've got 3b over 2. This will become negative 2 over 4 minus 19 over 4. So let's jump up here. So I have 3b over 2. Here, we're subtracting two fractions, so we have the common denominator. Now we can do negative 2 minus 19. That will give us a negative 21. And the denominator stays the same, over 4. So we have 3b over 2 equals negative 21 over 4. I want to solve for b. Let's do the trick of multiplying by the reciprocal. If I multiply both sides by, instead of 3 over 2, 2 over 3, we'll do it to both sides. On the left side, everything will cancel. So I get just b. And on the right side, we could multiply this all out and then reduce the fraction. But if we're a little bit tricky, we can already reduce it before we multiply. So I notice that I have a 2 up here and then a 4 down here. And I know 2 goes into 4 2 times. So 2 goes into itself 1 time, and into 4 2 times. So I can already reduce that. And then 3 goes into 21 7 times. 7 times 3 is 21. So 3 goes into itself 1 time and into 21 7 times. So I can already see that this will reduce to negative 7 over 2. And that will be our solution. So this one was more lengthy. It kind of combined everything together. We used addition and subtraction in order to move things over to the other side of the equation. We cleared out parentheses. There's some fractions involved. And notice it was multiple steps. I had to go off on the side, do a little bit of scratch work. had to use multiple techniques, and there were probably many different ways we could have gotten to this solution. We could have done things in slightly different orders, but as long as you follow all of the rules of equality and moving things over to the other side, using the opposite operation, working with fractions, following the rules of fractions, you should arrive at the same result, at this negative 7 over 2. There's many paths to the same destination in algebra. All right, so that wraps up section 2.1. And this was about solving linear equations, part 1.